Hello, everyone. Welcome to another session on Python for data science. So today we'll discuss on generators. So I think generators, similar to the previous session on decorators. So it's mostly based on functions. Right? So functions are sort of the basic building blocks of both of them. So coming to generators, basically, what are generators? I think generators, again, to put it simply, generators is nothing but functions. Right? The basic fundamental difference between a generator and a function basically is how it executes. Right? So functions, I think, as by now you would have known. So it's like once you run a function, sort of the intermediate variables, the intermediate states, none of it is stored. Say, consider a function where you're trying to basically add two numbers. Right? So once you run that function, you cannot access whatever intermediate variables you have. Right. Just to give you an example, say suppose this is a function where you're adding two numbers. So basically over here you have the I and you're returning the value. So now whenever you just try to print out the value of I, you basically end up getting an error. Right? So this is what is common with functions. So the problem with functions is, so whatever intermediate values, intermediate states, it does not get saved. So once you execute a function, it more or less completes the process. So this is where generators fit in. The basic fundamental difference between them is, so generators sort of do not execute at once. So you basically, uh, so basically generators, you have an option to run sort of after your first iteration. So generators basically freezes the intermediate state. So whatever values are there, whatever variables are there, it will get saved. So next time whenever you execute it again, it basically starts from that particular point. So basically, generator is a function, okay, which gives out a generator object. So on the generator object, you can basically apply a function which is called as next. So each time you apply next, the code executes only for that particular specific iteration. Right? So each time it basically applies next and it executes, applies next and it executes, applies next. Right? So this process continues until you basically it teaches something called a stop iteration. Basically, it means it has run out of all options. Right? So this is what the basic generator is. Coming to basically how, in terms of code, how it is different from normal functions is, one major difference between that of generator and a function is basically how it is written. So this is how a normal function is written, right? You add a def followed by the name, followed by arguments it has, followed by the return statement. So what happens in a generator is, uh, it's everything is the same, except the only thing which is different is you basically have something which is called as yield. So yield basically is whenever you put a yield in a def statement, it basically ends up being a generator. So yield is yield and return. So that's how basically functions are generated. So let's look at an example where you have basically you created a generator mygen, and you're creating a generator object as well. Just for confirmation, see, this is nothing but a generator object. This is just mentioning the location of it. Now, whenever you try to apply, say, you just do a G of 4. Right? So this error which you get is this particular generator object is not callable. So one way of operating this or accessing this generator object is basically whenever you use a next keyword to it. So whenever you use a next keyword, it gets executed. Okay, so over here you need to put a next to the generator, right? So it's say next of G, Okay, so let me put it as next of G. It basically gets executed for 6. Now again, when you just type next of G, so this keeps on running until you basically reach your stop iteration error. Right, so it basically reaches to stop iteration error because since it does not have any since it does not have any loop or anything like that, so it immediately stops. It immediately raises the stop iteration error. So this is what the general difference between a function and a generator is. So you first create a generator object. Creating a generator object is the main part. So this is similar to your function. So the way you call your functions, right? You just call the function name and you pass in the arguments. It's very similar to that. So you just call my underscore gen of 6. So 6 is basically the argument which you need to pass. So the only difference over between function and this is, so function once you run, it's run, you get the output. So you can't call it again next. So when you actually compare this mygen with say a function is, once you call g is equal to mygen of 6, it's done. So you can't again sort of run a next or because functions do not store your intermediate states. Right? So basically generator does. So that's what the major difference is. So other than that particular difference, you can't. So in functions, you can't basically call next of this thing, next of that. So it basically runs only one particular time. All right. So you just call it only once. So whatever the intermediate state is sort of frozen every time you call the next. It basically starts executing from the previous iteration. Okay. So it's commonly where it is commonly used wherever you're sort of processing huge data points. In those sorts of cases, you're basically using the generator a lot. So it's also used in sort of infinite sequences. I think one of the most commonly used infinite sequences is sort of your Fibonacci sequence. So we'll write a very simple generator just to explain all of that. So you keep on running this while a is lesser than the limit. So this is basically is what is generator, Fibonacci generator. Now we basically need to iterate over it, right? So you basically say fib of 5. So this is where this is I think again very similar to your function, right? You just call a function name and you just run it. So this is very similar to your function. Now basically now you got this. Now suppose you want to run your next this thing. So you just do next of x. So now you get the starting point. Or here, since you already initialized a and b as 1, so you get the starting now. So again, you do a next of. So there's actually one more way to call this next. Instead of using next as a function, you can basically call this as well. This one also would work. So you can just call up. You can just put it in a sort of print statement. Okay, so this is giving it output. So you can just say next of x. So it keeps on running. So it keeps on running until maybe when it reaches that particular limit, right? While a is lesser than limit, so limit is 5. So whenever it reaches that 5 limit, it basically stops and gives you that error. Right. So one more way of calling that is say for I in fib of 9. Right. So fib of 9 is basically that output. So you can't basically expect to have this sort of cases while writing functions. And so you can basically say you can iterate over the output, whatever be the output is. But you now basically what you're doing is that each time you're calling the code to execute, each time you're executing the code in this loop. So you just write for I in fib of 9 print I. So each time you're calling that I, each time you're basically executing that function, right? Function or generator. So this is what the basic idea of a generator is. So you can easily use it in sort of loops or any sort of condition. But you sort of basically get one particular iteration, sort of the intermediate states frozen or saved, and you can reuse. Okay, then thank you. We'll again meet in the next session.